Texan Global School. Systems of 3 linear equations in 3 variables. A 3 by 3 system of equations is one composed of 3 equations in 3 variables. Solving these types of systems implies using the methods seen in previous classes such as elimination, equal values, or substitution. This is done by combining the equations, equation 1 with 2 and 3, 2 with 1 and 3, or 3 with 1 and 2, as shown in the diagrams. By the method of elimination, we must decide whether to eliminate x, y, or z, adding or subtracting the equations. By the equal values method, we must isolate the same variable from the 3 equations and equalize. By the method of substitution, we must isolate a variable from one of the 3 equations and substitute it in the other 2 equations. The determinants method for a 3 by 3 system will be seen in later classes since the algorithm changes a bit from the one seen previously. After involving the 3 equations using one of the methods, the 3 by 3 system will be reduced to a 2 by 2 system, which must be solved. Finally, it is suggested to substitute the 2 variables obtained in one of the initial equations 1, 2, or 3 to obtain the last variable. To verify, we must substitute the obtained values of x, y, and z in the 3 equations separately. If the 3 equalities are fulfilled, it means that the solution is correct. Let's see an example. We will solve the following system. We can see that it has 3 equations with 3 variables. We name each equation. Using the method of elimination, if we analyze the equations, we can cancel z directly, if we add the equation 2 with 1, and also if we add 2 with 3. We can also cancel x or y. In either of these last 2 cases, we have to use properties of equalities to cancel the variable between the equations. However, it is suggested to analyze first to find the easiest possible path. Adding 2 to 1, we see that z cancels and we get an equation 4. Adding 2 to 3 also cancels z, thus getting an equation 5. So, by canceling the variable z, we see that the 3 by 3 system reduced to a 2 by 2 system. We can solve it with any of the above methods. In this case, we will use the Kramer method. So, the determinant of the system is -4, the determinant on x is also -4, and the determinant on y is 8. So, doing the quotients, we get that x results in 1, and y results in -2. Once we obtain the value of 2 variables, it is suggested to substitute them in one of the initial equations 1, 2, or 3. We decided to substitute in 1 to obtain z. Then, by substituting values and solving, we obtain that z is equal to 0. To verify the result, we must substitute x, y, and z in the 3 equations separately. As we can see, the 3 equalities are fulfilled, so the solution is correct. In this next example, we will solve this 3 by 3 system, starting with the equal values method. In this case, we must isolate the same variable from the 3 equations. Once again, it is suggested to analyze the equations first to identify the simplest possible option. We then decide to isolate y. Isolating y from 1 results in y equals to 1 plus 2x plus z. Isolating y from 2, we get y equal to 2 plus 3x plus 2z. Isolating y from 3, y equals 1 minus x minus z. Now, we will involve those equations with each other. We will use the equal value of 3 with 1 and 3 with 2. In this way, the 3 by 3 system was reduced to a 2 by 2 system. We will solve it by starting with elimination, by canceling z. In this case, we must adapt the equations using properties of equalities. So, we multiply equation 4 by -3 and equation 5 by 2. In this way, adding the equations cancels z and solving, we obtain that x is equal to 2. We can repeat the process by adding y subtract, however it is easier to substitute. We then substitute the value of x as 2 in equation 4. We obtain that z is equal to -3. Finally, we substitute the values of x equal to 2 and z equal to -3 in any of the initial equations 1, 2, or 3. We decide to substitute in 3, thus obtaining that y is equal to 2. Once again, to verify, we substitute the obtained values, and we see that the 3 equalities are fulfilled. In this last example, we will use the substitution method. We must isolate a variable from one of the three equations and substitute it in the other two. For simplicity, we will isolate y from 1 and substitute it into 2 and 3. Solving then for y from 1, we get y equals 1 minus x plus z. We will substitute this equation in 2 and 3. In this particular case, it was not reduced to a 2 by 2 system, but it directly gave us the results of x equal to 2 and z equal to 1. Finally, we substitute these results in one of the initial equations 1, 2, or 3. We substitute x equal to 2 and z equal to 1 in 3, thus y results 0. Once again, to verify, we substitute the obtained values and we can see that the three equalities are fulfilled. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com